everybody, welcome back to another fun and exciting pre-calculus class. Today we'll be continuing in chapter number 11. We're going to do lesson 3, that is on page 208 in your textbook, page 208. Let's dive in there. Page 208, what we're going to be doing is we're going to be talking about how the angle, this is kind of like a continuation of last lesson, but basically last lesson we were talking about the rotation from the x-axis to the line. In this lesson, we're going to be talking about the rotation from one line to a different line. All right, so look at figure 11D. All right, so look down here, the blue line. You can look in your book, that's fine, and kind of, go back and forth. Your book, you might be able to see it a little bit better. But this blue line right here, in this case, it's called line 1 or line I. So the blue line. Now, yesterday, or in the last lesson, we talked about the angle from the x-axis, so down here, to the blue line. Today, in this lesson, what we're going to be talking about is actually this rotation from this blue line, this theta right here, this rotation right in here. When we take this and we turn it so that it sits on top of the next line, how can we find this angle right here? In other words, this angle right here between the blue and the red line. That's what we're looking for, okay? The other one that we're also looking for is this rotation between the red line back to the blue line. So this theta right here, this phi, I guess it is. So that's the theta up here, and this is the phi. So going from the red line, rotating it into the blue line. So there's really two things going on. The blue line is rotating to the red line, and then also you can think of it as the red line rotating to the blue line. So it's going to be, basically each problem is going to be two different rotations. So the first line rotating to the second line, then the second line rotating back to the first line. Okay? And both of these would be counterclockwise rotations, because if we take the blue line to the red line counterclockwise, and then we take the red line to the blue line clockwise, that's the same rotation. So we're doing both of them counterclockwise. So the blue line is rotating to the red line counterclockwise, that's our theta up here. Then the red line rotating to the blue line, that's our phi right down here. Okay? There's a lot of stuff going on in this. This is kind of like the delineation of the formula, like how you get to the formula. Notice that theta plus the alpha 1 equals the alpha of the t. Actually, this is the I line and the t line. And the theta of the alpha angle of t minus the alpha of the I line. Basically, they're showing you how to get to the formula. Notice that also the phi of the 180 degrees minus the theta. It's also helpful to sketch this. They're just showing you kind of like the how to do it. Let's kind of, in a way, skip all that. Because that's like a brain hemorrhage right there, waiting to happen. And let's just look over here at this next page. We're going to do the example. And what they do in the example is they give you the formula of how to do it, okay? The slopes of these lines, line 1 and line 2, are 1 and -2 respectively. So what does that mean respectively? So in other words, the line 1 has a slope of 1, and the line 2 has a slope of -2. So you'll want to go ahead and write that on your paper that you're doing your work on. You can see here I've written it on my computer screen. So the M1, I'm calling that the slope of line 1 is 1. The slope of line 2 is -2. So let's go back and continue looking through this. Now we need to find the angle that line 2 makes with line 1 and the angle that line 1 makes with line 2. What I've done here, you can see I've kind of blown this up so you can look at it a little bit closer. So they've drawn a diagram. You don't necessarily have to have the diagram, but I think that it will help you. So here's line 1. They want you to do this rotation right here. All right, so let me rotate that in with, this is the blue one. So we're going from there to there. This is our theta, okay? That's the angle that they want you to find. The next one, and we'll wait on this just a second, but the next one is the rotation, this red line rotating down to the blue line. So we're going to do these one at a time, but basically the next one is this rotation of the red line to this blue line, and that's going to be your phi right there. I kind of covered it up a little bit, but that's your phi. So your theta is the blue line to the red line. The phi is your red line to the blue line. So that's what's going on, and that's what we're going to be rotating in here. How are we going to do that? Let's go back here to the book, and let's look at how they did it. So we're going to take the theta equals. So remember what's theta? Theta is this one right here. Theta is this top one, the blue line to the red line. Okay, so how do we get that? We take the angle 2 minus the angle 1. Okay, what are those? How did we get those angles? Well, we had to go back up here and we have to talk about, we already have the slopes, right? So if we have the slopes, then we can find the angles. That's what we need to do. So let's come back over here to the computer screen and let's go ahead and work through this. So what we want to do is we want to say, okay, what is the alpha 1? We have, or what is the inclination 1? And then what is the inclination? Actually, they call it the alpha 2, okay? So we need to find these two things. If we don't have these two things, then we can't solve this. So let's kind of go back to where we were yesterday, right? So we had the whole slope equals the tangent of alpha thing, right? So that's what we need to do here to get this to come out right. So our slope in the first one is 1. So 1 equals tangent, and this is the 1 of alpha 1. How do we do that? We divide both by the tangent. So that's going to cancel, and the tangent. So in other words, we do tangent -1 of 1. So let's go to our calculator and let's go ahead and solve that. So what is the tangent -1, or the arctangent is another way to say that, of 1? That equals 45. So our first angle is going to be a 45-degree angle. So you're going to come back over here, and our angle 1 is going to be 45. Now, we need to find our angle 2. How do we do that? Well, we do the same thing with -2. So just come back to your calculator, and you're going to do the same thing now, except for we're going to do that with -2. And that gives us a -63.4 degree angle. -63.4 degrees. Now, if you remember from last lesson, we can't have a negative right here, okay? Because our angles can only between 0 and 180. So we need to rotate, we need to wrap this into the second quadrant. How do we do that? That is, we need to add that to 180. So plus 180 equals, and that's going to be 116.565, or I'll do 116.57. So 116.57. Now, remember, don't use that negative angle in there, because that negative angle is not the angle we're using. We have to be in between the 0 and the 180. Okay, again, that was from yesterday's lesson. All right, now what we have to do is, let's kind of skip back over to the book, and now what we have to do is we have to figure out, okay, so now that I know the alpha, I know that the angles there, what do I do? Well, all you're doing here in this first one, you can look at it. So if you kind of go back here to page 208, you'll see that, so what we do to find our theta is we just take our angles and we subtract them. So we take the second angle and subtract the first angle. So, going back here to this problem, is we're going to take our first angle, our 45, and we're going to subtract it from our second angle, our 116. So that's all we've got to do. So come back here and just do 116.57 minus 45. So go to your calculator and you're just going to hit minus 45. That's all you need to do, minus 45. And that's going to equal 71.56 or 57. So 71.57 would be our answer. We would probably want to round that off. I talked about this in yesterday's to 1 decimal point, so we'd round off to there. So 71.6 degrees would be our angle of rotation, and that's our theta. That's our theta equals that. What was our theta? Let's jump back over here. What is our theta? So this is the angle of rotation right here. So this would be a 71.6 degree angle between those two lines. Okay. Now we need to work on this other side. We need to figure out what this rotation is. Again, we're kind of already done with the work as far as we already have the base angles. So then we just need to go back through and think through it. So how are we going to get this one? So come back over here to page 208, and to find the phi, which is this angle right here going from the red to blue basically, to find the phi, we do 180 minus the theta. 180 minus the theta. It's just that simple. So we just come back over here to our problem that we're looking at. So we want to just subtract this from 180, and we're going to get the answer. So our answer would be, so here's our phi. So we're just going to do 180 minus 71.6. And you can use your calculator for that real quick. So 180 minus 71.6 is going to give us 108.4 would be the correct answer. 108.4, and that's for our phi equals 108.4. All right, and there it is in the book. Hopefully you were following along. Our phi equals. Notice that it doesn't say neither one of these are equals. They are both approximately equal to. So we'd want to put our bacon on both of those. So we can go back over here and kind of clear this out right here and change both of these to approximately equal to. So these are bacons now. Why are they approximately equal to? Because the calculator rounded off, we rounded off, and so they're not exactly equal to. Those are approximated values. All right, one more thing in the book, and we'll be done with this lesson. It says that 2 final observations regarding slope need to be made. If lines are parallel, their inclinations are equal, because they're the same. They're both parallel. They're both doing the same thing. You know, no matter where, what their inclination is, it's equal. It's always equal. So if you look down here at this table B, parallel lines, inclination will be equal, slope will be equal all the time. For perpendicular lines, okay, those are lines that form like a T, right? The inclination is always like I guess the right word is not the opposite. But basically it's adding 90 degrees. It's rotating at 90 degrees is what you're doing, whether it be adding 90 or subtracting 90. So what does that look like? Well, when you come over here and you have a perpendicular line, the slope of a perpendicular line, remember, is always the negative inversion, okay? So here's what that looks like. Negative inversion of slope. Let's say your slope is 1/3, okay? The negative inversion of that, so this would be to have a perpendicular line. You would have, the slope would now be -3/1. So you just take your fraction, whatever slope is, you flip it, and then you put a negative sign with it. So let's say slope was -2. For example, the perpendicular of -2 slope would be, so you take the negative away now, or you add another negative, and negative equals positive. So now that would be +1/2, okay? So the perpendicular slope of -2 is +1/2. The perpendicular slope of 1/3 would be -3/1. So back over here to your text. The only thing with inclination on a perpendicular line is it would be adding or subtracting 90 degrees based on what? Based on obtuse or acute angles, and based on keeping it in the second quadrant. Because remember, all inclination has to be in the second quadrant. So if it's an obtuse angle already, then you would subtract the 90 degrees, and that would keep it between the 0 and 180. If it was an acute angle, you would add the 90 degrees to it, and that would also keep it between the 0 and the 180. That's all I have for you in this lesson. I hope you learned something there. If you missed anything, be sure to slide it back, take another look at it. Lots of, basically in this lesson, if you can keep these things straight, if you can understand, okay, what am I rotating? My theta looks like this, my phi looks like this. So drawing the little graph, I think, is important. That way you can visualize what you're actually doing. If you can do it without the graph, if you can do it without the visualization, then that's great. But probably a good place to start is actually drawing your lines on a piece of graph paper. Then you can see what the lines are doing, and then you can visualize your angles. You can visualize your theta, you can visualize then your phi, and make the proper rotations in there. Okay, that's all I got for you. Hope you learned something. Have a good one. Bye-bye.